Welcome to United Fire's Extinguishing Agents 101, Understanding Clean Agents. For the purposes of this presentation, I'll be playing the part of Blake Moore. So in order to get a better understanding of agents and understand how fire affects them, we need to understand fire first. Fire was initially comprised of a triangle made up of three parts: oxygen, fuel, and heat. Eventually, a fourth side was added to that triangle, creating what we call the fire tetrahedron. Fire tetrahedron, the fourth side, is the sustained chemical reaction, otherwise known as pyrolysis. Now, fire can be broken down into three classifications of hazards. There's Class A, which equals flammable solids such as paper, wood, trash, etc. Any flammable solid that can catch fire and sustain the fire. Next, you have Class B, which is a flammable liquid, things such as gasoline and jet fuel. Last is Class C, which are energized electrical equipment components. Anything in a data center, computers, server rooms. Anything that's in Class C can also be Class A. For example, computers unplugged, doesn't have a current running through it, it still now becomes a flammable solid as opposed to energized electrical equipment. But those are the three classifications of hazards under which fire exists. Now we're going to discuss agents, beginning with CO2, also known as carbon dioxide. Carbon dioxide, or CO2, is garnered under NFPA 12. It's also known as the oldest extinguishing agent on the market that's currently being used, being first introduced back in 1921. CO2 is an inert gas that works by lowering the oxygen percentage below that is required of fire to burn, which is 15% oxygen. However, that makes it toxic to humans who require 21% oxygen in order to breathe. Now, carbon dioxide works in two diversion paths. If you'll recall, we discussed that it reduces the oxygen content required by fire to burn below the 15%. However, it also reduces the heat, thereby lowering the flash temperature. If you recall, we discussed the flash temperature earlier in the presentation. That's very important to understand that what ignites is vapor, not liquid. So if we use the example of a gas can, if we were to go ahead and submerge that match into the gasoline liquid, it would actually extinguish that match. However, it's the vapor before the match gets to the liquid that's igniting. Carbon dioxide is used under very specific applications only because of its toxicity towards humans, mostly in industrial applications where human access is limited. And it's also listed to suppress Class A, B, and C hazards.